Hello, everyone. My name is Professor Jack Burns from the University of Colorado in Boulder, Colorado. I want to join you all in celebrating today's inauguration of the Embassy of the Moon. It's an opportunity to bring together an international group of individuals in the sciences and the arts and the media to work on preserving the best attributes of the moon for both scientific and commercial purposes. Someday in the future, maybe we will have an actual embassy on the moon, like what we see here in this AI generated picture of such an embassy on the surface of the moon. Um, the the moon is already becoming very important scientifically. We had just last year the first commercial payload brought to the moon in one of NASA's commercial lunar payload services rocket launches, and it brought the first radio telescope to the moon. On the right hand side, you see a picture of the SpaceX rocket that carried our lander to the moon. And in the background, you see the crescent moon, our eventual destination. And then on the left-hand side is a picture of the lander. And just above this orange-looking cylinder, which is a helium cryogenic tank, is actually where one of the 4 antennas was that we carried to the moon. On the moon and on its way to the moon, we were able to take the first radio data from the moon of the Earth. Looking in the middle here is that data. This is radio frequency versus time, and all the horizontal stripes that you see here is actually transmitters coming from the Earth. This is what we call a technosignature. So in other words, this is what we expect to see from a technological civilization. So this is now a template for us that we can then use in exploring nearby exoplanets. So can we detect the radio signatures from a nearby exoplanet like the cartoon picture you see in the left-hand side of the screen? And the answer is potentially yes, doing it from the far side of the moon where it is radio quiet and where we can put down a large array of dipole antennas to survey the nearest exoplanets out to about, say, 50 light years or so. And doing that kind of array, we have been studying that with some NASA funding. And the current design array is called FarView. And here's a little video talking about that.
FarView is a technology concept for a next-generation astrophysics radio observatory that could be built on the moon's far side. The only radio-quiet place within the inner solar system to study the earliest stages of evolution of the universe. The Lunar Observatory would be built from lunar resources and constructed directly on the surface of the moon using space industrial equipment sent from Earth. The required materials would be extracted by Lunar Resources manufacturing technologies from the lunar regolith. A truck rover then delivers the extracted raw materials to the construction site for the fabrication of antenna elements, solar cells, electrical transmission cables, and batteries. The observatory's antenna array and power grid could then be assembled directly onto the surface of the moon, utilizing Lunar Resources space manufacturing technologies and its partners' intelligent lunar rovers. FarView is planned to be a 14 by 14 kilometer observatory with 100,000 dipole antennas and could take less than 4 years to be constructed. The Lunar Observatory could explore the origins of the first structures in the universe, opening new windows into low-frequency radio astronomy, uncovering new physics, testing standard cosmological models, and enabling new discoveries in heliophysics and planetary science. Farview could be one of the most powerful radio observatories for learning about the formation of the earliest structures in our universe.
So at Farview, we bring together both the commercial and the scientific sides to explore the early universe. And in so doing, it's important that we preserve, as I mentioned before, this radio quiet of the far side. And here's where the Embassy of the Moon would be a perfect venue to bring together an international audience that includes scientists and technologists, folks from industry and from government, to look at preserving that radio quiet. We're already concerned about this because in Earth's orbit, the Starlink satellites leak low frequency radio emission from their power supplies and other electronics, and that could be devastating if we had equivalent satellites like that in lunar orbit. So we look forward to these discussions and look forward to the Embassy on the Moon. Thank you all.